Hi, my name is Hagen Fritz, and I'm going to be talking to you about our particulate matter sensor network that we developed on the University of Texas at Austin campus. We created a sensor network because we wanted to monitor particulate matter pollution across campus. Establishing our network on campus made sense because we had access to a reliable IoT network and power supply. We also hoped to identify any hotspots on campus. The university is located just north of central Austin and is surrounded by 3 major roadways and a heavily trafficked highway to the east, shown in purple. Sensors could be mounted to any emergency call box on campus, which provided a constant power source. The sensor itself is a purple air outdoor particulate matter sensor that was painted yellow to match the call box. We placed 16 of these sensors across campus. We chose locations near the major roadways as well as those that were near potential sources like buses and on-campus power stations. Our sensor network, called the Bleed Orange Measure Purple network, is unique from others in that it is more densely concentrated. This figure shows our sensor network in relation to 2 government-funded air quality monitoring sites overseen by the Texas Commission for Environmental Quality. This heat map shows measurements made by each of the sensors in our network for just over 9 months. Data shown are daily averages. We can see that our sensors tend to read similar concentrations all across campus with some slight variation that could be due to geographic distance or simply measurement noise. Gaps in the heat map correspond to sensors that went offline or made erroneous measurements. At the bottom of the figure, we also show measurements made by the TCEQ sites, which employ higher grade instruments. Our network appears to identify similar trends to what the TCEQ sites measure. Each of our purple air sensors is made up of 2 PMS 3003 sensors. We are showing you the daily average measurements from both sensors in each purple air module in our network. Red points indicate measurements that were removed based on the value and percent difference between sensor A and B's measurements. Overall, we were able to develop a reliable sensor network that reported measurements agreeable to those made by high-end instruments. We were not able to identify any hotspots on campus, but we hope to deploy our own high-grade instrument on campus to verify the purple air measurements and develop a model to correct the purple air readings.